All right, let's talk about forces. And of course, when we're talking about forces, we're going to talk about Newton's second law. And remember, a force is a push or a pull. And if we're talking about Newton's second law, what we're talking about is F equals ma. Force equals mass times acceleration. And any time that we have an unbalanced force, unbalanced meaning that the two forces opposite each other are not equal, then we're going to get acceleration. We're going to have some type of acceleration when we have that. Together, if we have these two forces, we call that the net force. Whatever that net force would be in there. And if we're talking about, if we're looking at our force equation here, F equals ma, remember that mass we measure in kilograms and acceleration we measure in meters per second squared. So of course, 1 Newton is equal to 1 kilogram per meter times meters per second squared. And, I like how they talk about, if you want to get an idea of what a Newton is, it's about a stick of butter. So if you think about that. If we want to talk about a specific force and we want to talk about weight, weight is our mass times a specific acceleration, which is gravity. On Earth, we'll use 10. And so whatever your mass is times 10, that would be your weight in newtons. Whatever your mass is in kilograms times 10. All right, let's slide this down a little bit. Let's work through a couple of examples here. So we have our first one. It says Felicia, the ballet dancer, has a mass of 45 kilograms. Mass 45 kilograms. Want to know what her weight is? Well, weight is mass times gravity. 45 kilograms times 10 meters per second squared. Of course, that's going to be 450 newtons. So 450 newtons. Then the second question says, what is her mass on Jupiter, where the acceleration is 25 meters per second squared? Well, mass never changes. So on Jupiter, she has 45 kilograms on Earth. She's still going to have 45 kilograms on Jupiter. That's going to be her mass, because mass is not related to the pull of gravity or to a force. But if we wanted to figure out her weight on Jupiter, her weight is now going to be the 45 kilograms times the acceleration on Jupiter, which it said was 25 meters per second squared. So that's going to obviously give her a little bit different weight. So if she's standing on a scale on Jupiter, she's going to weigh 1,130 newtons compared to her 450 when she's on the Earth. All right, let's do example. Oops, come on here. All right, I'm not doing very good at this. There we go. Okay. Butch, the 72 kilogram star quarterback of Belmont High School's football team, collides with Trask, a stationary left tackle. Probably should have made a little bit of a move to get around that guy. Would have been a little bit better. And is brought to a stop with an acceleration of negative 20 meters per second squared. Now, whenever you see this negative, you can assume that the acceleration is opposite the direction that he's going. So here's Butch. He's running. Doesn't make any fake. Tries to just run over Trask, apparently. And he gets stopped. So the acceleration is in opposite direction of the way he was going. So what force does Trask exert on Butch? And what force does Butch exert on Trask? So my acceleration, now notice that they have G, and that is completely wrong. There's no gravity involved here. I'm not talking about that. It should just be A. negative 20. And all we're going to do, this is pretty simple. It's our F equals ma formula. And we're going to take 72 kilograms times that acceleration of negative 20. And, we're going to get negative 1440 newtons for that. Now, if he runs into Trask and he applies a force of 1440 or negative 1440 newtons, well, guess what? Trask is going to exert the same force, equal but opposite. So if this was negative 1440, Trask would be applying 1440 newtons. Okay, equal but opposite. All right, example 3. A 20-gram sparrow flying toward a bird feeder mistakes the pane of glass in a window for an opening and slams into it with a force of 20 newtons. Bet he won't do that again. What is the bird's acceleration? Well, let's write down what we got. Mass, 20 grams. Now, in here, we're always working in kilograms, so let's just convert that. 0.020 kilograms. And the force was 2 newtons, and we want to figure out acceleration, so we're using our same formula, F equals ma, and we're going to plug in the things that we know. Well, we know force, 2.0, can't write newtons, equals 0.020 kilograms times my acceleration. And if I divide, I'm going to end up with, well, and actually, as I look at this and I'm looking at their problem, we should write it's negative because the force is opposite the direction he's going. So here's the bird, runs into the window, negative 2 divided by 0.020, and we're going to end up with negative 100 meters per second squared. Now think about that. Falling gives you an acceleration of 10 meters per second squared. So this would be 10 times that. So this would be a force of 10 G's. I think that would hurt. Okay.